All right, so 7.3, we are going to discuss independent and dependent events. We're going to determine whether an event is independent or dependent and then find the probability. And then tomorrow we'll talk about how we can use tables to find conditional probability. So an independent event is an event where the occurrence of one event does not affect the probability of another. For example, the coin toss that we just did, or rolling dice, what you roll one time is not going to affect what you roll another time. Let's do an example together. So for the coin toss, let's do the probability of tossing 2 heads in a row. If we do that, we know that the probability of getting heads is 1 out of 2, 1/2, okay, 50%. That doesn't change on the second toss, as some of you guys saw with your trials. So it's still 1 out of 2. So if you were to toss the coin twice, the probability of getting heads would be 1 out of 4, right? Or 25%. What if you were tossing 2 tails? What would the probability be? 25%. What if it was 1 heads and 1 tails? It would be still be 1 out of 4, wouldn't it? Because both of them are a half. Okay, so the equation for this to find the probability of both of those happening is when you multiply the probability of the first event by the probability of the second. So we call these events by variables. So event A, event B. So the probability of A multiplied by the probability of B, you're multiplying the probability of each of those events. So with our first example, we have a 6-sided cube, and it's labeled with the numbers 1, 2, 2, 3, 3, and 3. Okay, so the number cube is like a die. It's just you have different values on it. And this one also has different colors. So the 4 sides are colored red, 1 side is white, and 1 side is yellow. Okay, find each probability. So when we're doing this, we are finding the theoretical probability. So we want to find the probability of tossing a 2 and then tossing a 2 again. So what we have to do is find the probability of tossing a 2 in the first place. So remember, the probability is going to be the favorable outcomes over the total outcomes. Damien, how many total outcomes do I have for this? 6. And then how many sides have the 2 on them? Damien? That. Okay, yeah, so you have 2 out of 6, which is going to reduce to 1/3. So the probability of tossing a 2 and then tossing another 2 is the probability of tossing a 2 and then tossing a 2 again, which would be 1/3 times 1/3, so 1/9. Okay, for B, we have to find the probability of tossing a red, then a white, then a yellow. Okay, so first we'll find the probability of tossing a red. So again, we have 6 sides, so that's going to be our total. Kelsey, how many sides are red? 4. Okay, so then we're going to reduce that to what? We have 4/6, that's going to reduce to what? 2/3, right? Divide them both by 2. Okay, and then we're going to find the probability of tossing a white. Alyssa, what's that going to be? Yep. Okay, so out of 6 sides, 1 of them is white, and then 1 side is yellow, so that's going to have the same probability, 1/6. So then we're going to multiply the probabilities together. The probability of the red, the white, and the yellow. So 2/3 times 1/6 times 1/6. You can either reduce at the end or you can reduce right now. So if you reduce at the end, you multiply the top, you get 2. What do you get on in your denominator? 108. So then you'd have to reduce. This would be 1/50. 54. All right, and then let's look at the last one. So the probability of tossing a 3. So the probability of getting a 3 is going to be 1/2, or 3 out of 6. Okay, the probability of getting a yellow, we already found that, is 1 out of 6. And the probability of tossing a red, we already found, was 2 out of 3. So we're going to multiply these together. Okay? So we're going to do 1/2 times 1/6 times 2/3. Okay, again, like I said, you can reduce first or at the end. Here you might notice that the 2's will cancel, so you'll have 1 over 18. Okay, questions for me so far? All right, now let's look at dependent events. So dependent events is if the occurrence of one event affects the probability of another. So one event affects the probability of another. Okay, so an example of this would be if you are the very common occurrence of pulling marbles out of a bag. And do not replace them. Or the more common occurrence would be drawing a card out of a deck and sometimes we just say without replacement. Okay, and the reason why that would be dependent probability is because if you draw a card out of a deck, first, your total outcomes in the bottom, that would be lower. And then depending on what card you pull, the probability on the top would be less. So when you are finding the probability of dependent events, okay, when you're finding the probability of A and B and they are dependent, A and B, okay, the equation is the probability of A multiplied by the probability, and then this is going to be a different symbol. It means B given A, or you can even think of it as the such that. So B such that A happens, kind of similar to like what we use in our set builder notation. Okay, so what that means is the probability of B given that A has occurred. All right, so for our second example, 2 number cubes are rolled. One is white, one is yellow. You're going to be given different situations, and in these situations, you're going to explain why the events are dependent. And then you're going to find the probability. So your first step is going to be to explain. The second step is going to be to find your probability. And then let's look at our first situation here. All right. So it says the white cube shows A, and it should be a 6. And then the sum is greater than 9. So the white cube shows a 6, and the sum is greater than 9. I'm going to get my next sheet. it. I really want this page. Okay, so the first step is to explain why the events are dependent. So the probability that the sum is greater than 9 is different when we know that a white 6 has already been rolled. For example, let's say on the white cube you rolled a 1. What would the probability be that the sum is greater than 9?
0.
It'd be 0. There's no way you could get a sum that was greater than 9. But if you have rolled a 6, are there going to be some values that you could roll where the sum would be greater than 9?
Yes.
Yes. So we're going to talk about those situations. So for step 2, we're going to just keep in mind it's the probability of the first event times the probability of the second event, given that the first event happens. So the probability of A really is the probability that you roll a 6 on the white cube. I'm just going to put roll a 6 on white. Okay, so the white cube is like a die. So you have a 1 out of 6 chance to roll the 6 on the white cube. One side has that. Okay, now we're going to do the probability of the B given A, which means you're finding the probability that the sum is greater than 9 if you already rolled a 6 on the white. So let's think about all of our outcomes, okay? We already know on the white cube we've rolled a 6. So on the yellow cube, if we want a sum that's greater than 9, what could I roll? So it says greater than 9, so not greater than equal to. So the lowest number you could roll and still be greater than 9 would be what? 4. Okay, so if you roll a 4, then that would be a sum of 10. If you rolled a 5, 11. If you rolled a 6, 12. Okay, so I have 3 choices on yellow out of how many possible? 6. So it would be 1/2. When you reduce, so then to find the probability of the entire situation, your probability, I'm just going to put of E, the event, is going to be 1/6 times 1/2, which would be 1/12. All right, now we're going to try the second one where we know the yellow cube shows an even number. And the sum is 5. Okay, so step 1, we're going to explain why these are dependent. Okay, so the probability that the sum is 5 is different when we know an even number has already been rolled. So when you're doing this, obviously we're talking about dependent at this time, so you know what equation you're going to use. It's really, when you have these problems in front of you, you're trying to decide, okay, does the fact that an even number is already rolled affect the outcome? So that's what you're going to be asking yourself. And yes, if an even number is already rolled, then that's going to affect how many times your sum is going to be 5. Because there are times where you have an odd number, you could have like 1 and 4. This is only going to provide you with the even ones first. So let's find that probability. So the probability of event A is the probability that the yellow cube is even. Okay, so if you are on a number cube, the even numbers are 2, 4, 6. That's how many out of the total? 3. Okay, so 3 out of 6, 1 out of 2. Now that one's a little bit easier, but if you ever are unsure, you can always list out the situation. So the total outcomes would be rolling a 1, a 2, a 3, a 4, a 5, a 6. The favorable would be a 2, 4, or 6. That's where we're getting the 3 over 6 from. Okay, and then we're going to do the probability that the sum equals 5, given that yellow is even. So when I do this, I like to write out what I have. So we know that the yellow is even. So the yellow cube could be a 2, a 4, or a 6. Okay, and then I have to think about what my possibilities are for the white cube. So if the yellow is 2, what's the possibility for the white cube? 3. Okay. If it is 4, then the possibility is 1. What if it's 6?
-1.
Can you roll a -1?
You could.
Okay, so not possible. So that would not count. Okay, so for you to get a sum of 5, you would have how many total possibilities here? Yeah, you'd have, yeah, so for this one, you're going to have a couple different possibilities. So because with the 2, you would have to roll the 3. You couldn't roll a 2 and then a 1, right? Would that get you a sum of 5? No. So the probability for this one would be 1 out of 6. So if you roll a 2, there's only a 1 out of 6 chance that that happens, right? Right? If you roll a 4, there's a 1 out of 6 chance of this happens. So to find this probability, you're going to have to find all of your total. So let's think about how many possibilities there are here, okay? So for this, you have on the white cube, you have 6 tries. This is going to be 0 out of 6. You have 0 out of 6 tries here. So when you're finding this probability, you're going to add up how many rolls there would be. So 6 plus 6 plus 6, which would be 18. And then you have one possibility here, one possibility here, which means you would have 2 out of 18. Okay, so I'm just going to go over that part again. So if you roll the yellow, there's only one possibility, okay? But the total possibilities for the white would be 6. Because this is a separate situation, for the 4, you have 6 more chances here, and then you have 6 more chances here. So the 18 comes from adding up your total, 6 plus 6 plus 6. And then for this one, you would have one possibility for the 3, one possibility for the 1. There's none here. And then that reduced to 1 over 9. So your probability for the sum equals 5, given that yellow is even, is going to be 1 out of 9. All right, now we have to find the probability of the entire event. Which would be 1/2 times 1/9. Which would be 1 out of 18. Okay, so remember when you're doing this probability, you still have to do your possible out of the favorable. Okay, and that's how you're getting your 1 over 9. We are going to save the tables for day 2.